That circle is called a unit circle. Why is that circle called a unit circle?
Special.
It has special. What's special about it?
It's the smallest circle, I think.
Oh no, I can draw smaller circles, right? I could draw a little one like this.
What's the basis for the scale, I guess?
It is the basis for the scale for discrete functions, you're right. Why is it called unit? What's a unit? Unit means one. So why is this called a unit circle?
It's all one.
What's all one? Begins with an R. Radius. The radius is one. So this is called the unit circle centered at the origin. Unit circle simply means it has a radius of 1. If I were to take and start right here and walk all the way around that circle, how far would I walk? Nope, I'd walk further than that. What's that called? The distance all the way around the circle. Circumference. How do you find circumference of a circle?
Pi r squared.
Pi r squared is
The area.
the area. How do you find circumference?
2 pi r squared.
Circumference is 2 pi r. So if I were to walk all the way around that circle, I would walk a distance of 2 pi. What if I only wanted to walk halfway around the circle? How far would that be? Pi. So going from here halfway around the circle, that would be a distance of pi. Half the circumference. What if I started from here and I only went a quarter? That would be pi over 2. Very good. All right, so then where is pi over 4? That's the same as 45 degrees, because this is pi over 2, a quarter of the way is pi over 2, so half of pi over 2 would give me pi over 4. So pi over 4 would look like that, pi over 4. How about 3 pi over 2? Think of 3 over 2 as 1.5. So where would 1.5 pi be? Close to quadrant 4. Close to quadrant 3. Well, where's 1 pi again? That's right there. There's 1 pi. So where's 1.5 pi? Where's another half pi? Where do I stop? Right there, wouldn't I? So this, if I were to start and walk all the way around, that would be 1.5 pi's. All right. How about 3 pi over 4? This is pi over 4, right here. So where's 2 pi over 4? Well, this is pi over 4. 2 pi over 4 would mean double that. So where's 2 pi over 4? Right here. Where's 3 pi over 4? I don't want Greece.
It's in between. It's in the second quadrant.
It's in the second quadrant. Very good. So if this distance is pi over 4, this distance is 2 pi over 4, another one would be 3 pi over 4. This one would be 4 pi over 4, which normally we just call pi. This one would be 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Basically, pi over 4 is 1/8 of the distance around. So I'd have to go 8 times to get all the way around. All right, pi we already did. How about pi over 3?
In between pi over 2 and pi over 4.
Excellent. Why is pi over 3 in between pi over 4 and pi over 2?
Just it's in between, I guess.
Because if I divide by 2, and then what happens if I take and divide by 2 and divide by 4? I get numbers, right? What happens if I then divide by 3? You get something in between. So pi over 3 is somewhere in between over here. Oops, pi over 3. And by the same argument, pi over 6 would have to be down here somewhere, wouldn't it? Because if I divide by 6, that's going to be smaller than when I divide by 4. Okay, so what does this have to do with radians? What is 1 radian? Can anybody draw 1 radian for me? No. Can you draw 1 degree? You can? Show me 1 degree. Oh, I don't need a protractor to draw 1 radian. How would you draw 1 degree if you didn't have a protractor? It's not easy, is it? Is it easy to draw 90 degrees? Yeah, very easy to draw 90 degrees, but not easy to draw 1. Here's how you draw 1 radian. I'm going to start with a clean sheet so it's easier. I take a piece of string and I measure that distance, which is how long? 1, because my radius is 1. I then take that string and I lay it right on this arc right here. And it's going to end up somewhere over here. So I want this distance, this arc length equals 1. That measure right there is called 1 radian. So 1 radian is the angle where the arc length of your unit circle is 1. In other words, if you have a unit circle, the radian measure and the arc length are exactly the same. So radian measure equals arc length in a unit circle. So when I was asking you questions like, if I went halfway around and called that an arc length of pi over 2, what would we call that angle in radians? Pi over 2. And this angle, when we went around here and we got to 3 pi over 2, that arc length is 3 pi over 2, so we would also call that angle 3 pi over 2. Okay, make sense? All right. So now, I want you to tell me, where is the angle 2.5? Now, when I say 2.5, I always mean 2.5 what's? Radians. What will I say if I want 2.5 degrees? I will specifically say 2.5 degrees. So if it's 2.5, it always means we're working in radians. So where's 2.5 radians? Well, let me ask you a question. If I go from here halfway around, how many radians is that? That's pi, right? Pi is about what? About 3.1. So where's 2.5? It's a little bit less than 3, isn't it? 2.5 is a little bit less than 3. So do I know exactly where it is? No, I don't know exactly where it is. But I'm going to draw it. I know it's about like this. It's got to be a little bit less than pi. 2.5 radians is a little bit less than pi radians. Okay. How about 1.07? Quadrant 1. Why quadrant 1?
It's less than
pi over 2 would be to here, and pi is about 3.14, so 3.14 divided by 2 is about 1.5, a little bigger than 1.5. So 1.07 has got to be a little bit less than 1.5. So it looks like it's somewhere over here in quadrant 1. 1.07. Looks like it's about there. How about 7.5 radians? That's quadrant 1 again? How come? All the way around would be 2 pi, which is about 6.2. So I've got to go another 1.3 roughly. So where is it in relation to this 1.07? It's more than it, isn't it? So it would have to be, but it's less than the pi over 2. So it would be something like that. 7.5 radians would be about there. More than one rotation. Should have had a third color. All right, flipping to the back. Given the angle pi over 3, find a positive and a negative coterminal angle. So how do you find a coterminal angle? What did you do when you were working in degrees? Not 180. If I gave you an angle in degrees, you would add 360 and you would subtract 360. Why do you add 360? Because that's one time around. And why do you subtract 360? It's one time around in the opposite direction. So if I'm working in radians, I'm going to take my pi over 3 and I'm going to add 1 rotation. In radians, what's 1 rotation? 2 pi is 1 rotation in radians. So it's the same thing. In degrees, we added 360 because that was 1 rotation. In radians, we add 2 pi. Now, here comes the fun with radians. What's the fun with radians? The fun is they always have fractions, don't they? So what do you have to do? You gotta have a common denominator. So we think of this as 2 pi over 1. So this is pi over 3 plus 6 pi over 3, 7 pi over 3. You're going to get lots and lots of practice with fractions dealing with radians. How about if I wanted the negative coterminal angle? I would take pi over 3 and I would subtract 2 pi. I would subtract 1 complete rotation. That's pi over 3 minus 6 pi over 3. Sounds like about minus 5 pi over 3. Questions on that? All right. Complement and supplement. What do those angles, what do those things mean? Complement means they add up to 90, and supplement means they add up to 180. So I need pi over 3 plus something to add up to 90 degrees, except we're going to write that in radians. We're going to write it as pi over 2. So I need pi over 3 plus something to add up to pi over 2. So what does that something have to be? Pi over 6. And how did you get pi over 6? That's the right answer.
Sure. Well, pi over 3 is 60 and pi over 6 is 30.
Pi over 3 happens to be 60 and pi over 3 happens to be, which one? 60. Yeah. And pi over 6 happens to be 30, and 30 and 60 makes 90. All right, well, if I wasn't converting, my answer would be this has to be pi over 2 minus pi over 3, and then once again I would have to get common denominators, add them up. Turns out you get pi over 6. How do you make all this fraction stuff easy using your calculator? What's that? put my calculator in radians. Okay. Mode, radians. So how do I take pi over 2 minus pi over 3 on my calculator? Pi over 2 minus pi over 3, and it just gives me some ugly decimal. I don't really need parentheses. Calculator knows order of operations. Calculator knows divide, and then subtract. But it doesn't give me pi over 6.
Because
Why not?
Because you're in degree.
No, I'm in radian mode.
I don't think you'll ever get it in pi over than that form.
Well, what you have to do is you have to be smarter than the calculator.
You know, if you like put 1 for instead of pi.
So if I'm going to take pi over 2 minus pi over 3, do you agree that the answer is going to have a pi in it? Yeah. So if I want to do pi over 2 minus pi over 3, here's what I'm going to do. I'm going to think of this as being 1/2 pi minus 1/3 pi. How do I take 1/2 pi minus 1/3 pi? Would you agree that this is the same as 1/2 minus 1/3 pi? What did I do? I factored the pi out. So if I want to use my calculator, and if I want to do pi over 2 minus pi over 3, I don't do pi over 2 minus pi over 3. I do 1/2 minus 1/3. I ask my calculator to give me that answer as a fraction. It tells me it's 1/6. So my final answer is pi over 6. That's how you use your calculator. You don't type the pi thing. You just accept that your answer is going to have a pi in it at the end, and you deal with the regular old fractions. So, if I want to find the supplement, what do I have to do? I need pi over 3 plus something to equal pi. So x is pi minus pi over 3. How do I do pi minus pi over 3 on my calculator? 1 minus 1/3, and then I write pi down when I get all done. So I take 1 minus 1/3. I don't need to do 1 minus 1/3 on my calculator. 1 minus 1/3 is 2/3. So my answer is going to be 2 pi over 3. So as normal, you handle all these fractions using your calculator and just accept that all the answers are going to have a pi in them at the end. Okay? That makes life a whole lot easier. That's the big thing students struggle with usually is the fractions. Use your calculator. All right, now something that is somewhat useful to do is to convert back and forth. So if I give you something that's in degrees, like 135 degrees, how do we convert degrees into radians? Divide by what?
1/180.
Close. No, further away. What do you know about 180 degrees? How many radians is 180 degrees? That's pi. So if I'm going to start with 135 degrees, I need to have degrees down on bottom so that my units cancel out, degrees cancel with degrees, and radians on top. So if I'm going to put 180 degrees down on bottom, how many radians do I need up on top? Pi. So if I start with degrees and I want radians, I multiply by pi over 180. And again, what I do is I take my calculator and I do 135 divided by 180. Doesn't matter. All I did is 135 divided by 180. Does the calculator care if that's radians or degrees?
Mm-hmm.
No. The calculator told me that's 3/4. So what's my final answer? 3 pi over 4. How about 6.3 degrees? I'm going to take 6.3 degrees and do what to it? Multiply by pi over 180 degrees. Again, I grab my calculator and I do 6.3 divided by 180. I ask my calculator to turn that into a fraction for me. It says 7 over 200. So what's my final answer? 7 pi over 200. Questions on that?
Are you always using 180 degrees? 180 degrees?
I always use 180 degrees. How come? If I wanted to, I could use 360 degrees, but then I'd have to use 2 pi up on top.
Okay.
I could use 90 degrees down on bottom, and then I'd have to use pi over 2.
Okay.
You can use any of them that you
I
want.
was wondering if you specifically chose 180 for like I can just do all of like any of them.
Yep, you can use any of them. The reason we typically pick 180 is because then we just have the 1 pi up on top. It makes it easier. But the truth is you can use any of the ratios that you prefer. All right, so now it says, convert to radian measure, round to 2 decimal places. So how do I take 15 degrees and convert it to radian? Pi over 180 still. The only difference here is they're saying round to 2 decimal places. So I simply take my calculator, I go 15 times pi, divided by 180. My answer would be 0.26. Nope, because this time it said round your answer to 2 decimal places. So notice I have the pi in my typing. So that's all I do this time.
Or you did here.
No,
In terms of pi.
right, notice the difference in directions. This one up here said in terms of pi. This one says round it to 2 decimal places. So watch your directions carefully. All right, I'm going to skip part B there because that's pretty much the same thing. How do I go the other way? What if I have something that's already in radians? Now it's 180 over pi. Why is it now 180 over pi?
Because now the pi's cancel out.
More importantly, the units cancel out.
Yeah.
They're both in radians. So if I want to take 5 pi over 3 and convert it to degrees, now the 180 degrees goes on top and the pi goes down on bottom. And that's convenient because the pi's both cancel out. I take my calculator, I do 180 times 5 divided by 3, and I should get 300 degrees. Part B is clearly a typo. Why is part B clearly a typo? It's already in degrees. So how do you convert that to degrees? They don't do anything. All right, so give me a different number that's not in degrees. Give me a nice radian measure. Pi over 6. All right, how would I take pi over 6 and convert it to radians? It already is radians. How would I convert it to degrees? Times 180 over pi. That happens to be 30 degrees. What if I gave you 26 radians? Is 26 a radian number? How come? Go ahead and put degrees on it. Can we talk about 26 radians? Yeah, we can. Just like back here, where was it? We talked about 2.5 radians. We talked about 1.07 radians. Does radians always have to have a pi in it? No. Usually it does, but not always. So what if I gave you 26 radians and asked you to convert that to degrees? You multiply by 180 over pi. So you would grab your calculator, you would do 26 times 180 divided by pi, and I guess that's 1,489.7 degrees. Big angle, 26 radians. Questions on that? All right, the last thing we need to do is we need to talk about some things called angular velocity and linear velocity. Unfortunately, we don't have time to do that today, so what does that mean? Now it means we'll do it on Wednesday. So Wednesday, we will finish up this section. We'll talk about angular velocity and linear velocity. And I promised you a quiz on Wednesday. Since I already told you in advance that you're going to have a quiz on Wednesday, what does that mean? It means it's not open book, it's not open notes, and you do not get to use your neighbor. It will be, well, what do you want it to cover? Multiplication. All right, so we did a lot of multiplication today, didn't we? We multiplied by pi over 180. We multiplied.